Okay, so this is a very short and brief revision for ray optics. So basically this chapter can be divided into two parts: reflection and refraction. Now, reflection has two major portions. One is the plane mirror and one is the spherical mirror. In case of refraction, there are certain things. The first is Snell's law. Then we have for plane surface, refraction with respect to plane surface. Critical angle and total internal reflection for a spherical surface. For prism and optical instruments. Okay, so the first thing is reflection. Now, let us say we have a very polished surface, and this is the silvered surface, and this is polished surface, or we can call this that the mirror. Then let us say a light is incident upon this particular surface, then we can consider the tangent over here. And with respect to this tangent, let us say we have the normal over here. And the reflected ray over here. So this is the incident ray and this is the reflected ray. And hence this angle is incident angle and angle of reflection. Sorry, this is a reflected angle. Yeah, that is it. Okay. In case of law of reflection, first law states that the incident ray, normal, and the reflected ray all lie on the same plane. And secondly, the angle of incidence is equal to angle of reflection. Okay. Now, what is the vector form of reflected ray? So consider a mirror like this, and we have an incident ray like this. And let's say this is the normal. And hence, this is our angle of incidence. So equal to angle of incidence, we will have the reflected ray R. So we can call this also as angle I. Okay. So you can say that this has a direction of I cap and this has a direction of R cap. And the normal has a direction of N cap. Okay. And let us call these angles to be theta. then we can write that r cap is equal to I cap minus 2 I dot n cap dot n cap. Okay, where these are just unit vectors along the rays and normal respectively. Okay, one important thing you must know is the minimum length of mirror to see one's reflected image. Acha, let us say we have the ground over here. Okay, and there is a man standing like this. Height is considered to be AB, or you can just put it as H. And let us say that there is a mirror over here. Okay, what should be the minimum length of the mirror so that this man who has a height of H can see his entire image? Okay, it particularly should always be half of the height of the man. The length of the mirror should be at half of the height of the man, provided that eye level of man is at the topmost point of mirror, and also eye level is at A. So the eye is over here, which is actually not a very practical situation, but we consider it like that. Okay. The next important thing is angle of deviation. For angle of deviation, how can we just say it? Let me tell you. Let us take up this figure itself. Now, actually, the ray should have gone in this path. This can be said as the original path of the ray, path of incident ray, in absence of any mirror. Okay, so the ray has actually deflected by a certain angle delta, and this is what is known as angle of deviation. How to calculate angle of deviation? Angle of deviation is equal to pi minus 2i. Okay. Now, let us consider another example where, say, there are two mirrors. One here and another one here. Okay, so let us say we have the incident ray starting over here. Hence, it will have a certain reflection, let's say over here, and then it will also have a second reflection like this. So the path of the light ray must go like this, right? Okay, the original paths with respect to both the mirrors are these, right? So how, what will be the deflections? One is this and another one is this, right? Now net deflection can be calculated as delta 1 plus delta 2, which will give us 2 pi minus 2 theta, where theta is the angle between the two mirrors, okay, rather than the incident angle. Okay. Now let us consider another thing. So let's say I have a mirror like this. Okay. Let us say we have this situation. Okay. And I am rotating this mirror by theta angle. So now the new position of the mirror is something like this. Let's say this angle is theta. Okay. Then if this is the new reflected ray R2, then the deflection of this reflected ray will increase by 2 theta. Okay. So this is for rotation of mirror. And this is deflection for two inclined mirrors. আচ্ছা তাহলে একটা শর্ট কোয়েশ্চেন, যে লেট আস সে দুটো মিরর রেখেছি আমি at 90 degree apart. Okay. And a random ray of light is hitting any one of the mirrors. So the net deflection of that ray of light should be how much? Hmm? Suppose two mirrors, 90 degree apart, 90 degree inclined to each other.
মানে থিটাটা 90 ডিগ্রি তো,
Exactly.
তাহলে থিটার জায়গায় 90 বসিয়ে দিলে ওটা 180 হয়ে যাচ্ছে।
Just pi. আনসার হবে শুধু পাই।
শুধু পাই
পাই বাই 2 বসিয়ে দিচ্ছি, তাহলে 2
হ্যাঁ
pi minus 2 into pi by 2, which is pi.
পাই বাই 2। হুম
Okay. Okay. Now let us say I am moving that entire mirror at a certain velocity. Okay. So velocity of image for moving mirror. Okay. So let me say that I have this same case, or this original case. Now consider that my object is not at any random angle, but rather but rather it is, let's say it is over here. Okay, this is the object. It's a point object. Okay. Now, let me say that, okay, so if this is the object, then around here should be the image of this object at the same distance, right? This is image. Now I am telling that this is moving at a velocity VO. Okay, so this is velocity of object. This mirror is also moving at a velocity of Vm. So the image will obviously move. Let us consider the velocity of the image to be Im. Okay, then we can say that Vim is equal to 2Vm minus V object. So we can have total of 3 cases in this situation. Okay. Case 1, object is moving. Case 2, mirror is moving. And case 3 will be both are moving. Right? Now, just put the velocity for case 1 in velocity of case 1. Velocity of image will be nothing but the negative of the velocity of the object. বুঝা গেল? আচ্ছা, wait a second. হ্যাঁ, okay, both are moving. In this case, Vm equals to 0. In this case, V object is equal to 0. And in both cases moving, both are non-zero factors. Okay. Now, acha, also remember these are all velocities perpendicular to mirror surface. Okay. Okay. The next thing that let us go to directly to spherical mirrors. Acha. Acha. For a spherical mirror like this, okay, for a spherical mirror like this, if the ray is parallel to the principal axis, then the ray meets at focus, right? This is the pole, and twice the length of focus, or the twice the focal length, we have the radius of curvature. right? Now, radius of curvature is CP, the length CP. Focal length is FP. And we all know that F is equal to R minus R by 2 sec theta, where this is basically theta. Okay? Acha. Now, if, this is important, if rays were paraaxial, what does it mean? Parallel
theta
to,
0.
yes, parallel to principal axis and very close to it, which implies that theta is equal to, or we cannot say equal to, we should say approximative to 0. Then focus is equal to R by 2. Acha. We all know that the mirror formula is 1 by F is equal to 1 by V plus 1 by U. Acha. Magnification. For magnification is defined as M is equal to image height by object height, which is also equal to the ratio of minus length, distance of image from the pole and divided by the distance of object from the pole, which is also equal to, from the mirror formula, F by U minus F. Okay. Now, few things. You should always put terms with appropriate sign. If image is erect or upright, magnification is positive. Okay, and vice versa. Acha. Acha, tell me one thing. Suppose the object is here, like this. This is the object AB. Okay, which is technically parallel to the principal axis. Okay. And the image formed is here. A dashed, B dashed. So, what should be the magnification of this? It should be length of image by length of object. Okay. Also, I will just mention 2 cases out of 6. So there are basically 6 cases or positions possible for image formation for concave mirror. Okay. Which is, one is from infinity, beyond center of curvature, at center of curvature, between center of curvature and focus, at focus, between focus and pole. Okay. Now, at these last at two cases, okay, I will just say two cases where you get magnified image. Okay. One is when the object is between center of curvature and focus. In this case, you get magnified real image.
Inverted হবে, হ্যাঁ।
Yes, of course, inverted. So you can also, in short, write that magnification is negative,
হুম,
and in between pole and focus. So it is
Magnified,
magnified,
virtual,
virtual,
erect.
and erect. So I can, in short, write that magnification is positive.
হুম,
Acha.
ফোকাসও ম্যাগনিফাইড হবে না?
Huh?
মানে যখন
No, no,
ফোকাসে রাখা হবে তখন?
at focus কি magnified হয়?
কনকেভের ক্ষেত্রে ম্যাগনিফাইড আর কনভেক্সে ডিমিনিশড হয় না ফোকাসে রাখতে?
দেখ, বেসিক্যালি যখন ফোকাল পয়েন্টে থাকে তখন তো ইমেজ ইনফিনিটিতে হয়, ইজন্ট ইট?
হ্যাঁ, হ্যাঁ।
তো ম্যাগনিফাইড বলবি নাকি, লাইক দেখ, ম্যাগনিফাইড বলতে আমি এখানে বোঝাচ্ছি যে উইচ ইউ অ্যাকচুয়ালি ক্যান সি অর ইউ ক্যান ফাইন্ড
হুম,
দ্য লেন্থ। এর ক্ষেত্রে ম্যাগনিফিকেশন কত হবে? ইনফিনিটি, রাইট?
হুম,
কারণ ইমেজ লেন্থ বাই অবজেক্ট লেন্থ যদি ভাবি, তাহলে ইমেজ ইজ ফর্মড অ্যাট ইনফিনিটি। সো
হুম,
অ্যাকচুয়ালি ম্যাগনিফাইড, হ্যাঁ বলতে পারিস, ইয়েস, বিকজ ইট ইজ পজিটিভ। হ্যাঁ, বাট হ্যাঁ, মানে টেকনিক্যালি বলতে পারিস যে ইট ইজ ভেরি 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 এনলার্জড, বলতে পারিস। আচ্ছা, হ্যাঁ, আচ্ছা, এবার আচ্ছা, হাউ টু ফাইন্ড দ্য ডায়ামিটার অফ ইমেজ অফ সান? সাপোজ sun is at infinity
এফ
over
থিটা
here.
হয় না ডায়ামিটার?
হ্যাঁ,
ডি ইকুয়াল টু এফ থিটা হয় না এখানে?
হ্যাঁ, হ্যাঁ, এক্স্যাক্টলি। যে যখন এই দুটো লেন্থ এখানে থাকবে, আচ্ছা সরি, ভুল আঁকলাম। তখন এই অ্যাঙ্গেলটা যদি থিটা হয়, তাহলে বেসিক্যালি এটা ফোকাসে ক্রিয়েট হয়, আর তখন এর নিজস্ব যে ডায়ামিটার ডি ওটা এফ থিটা হয়, কারেক্ট। আচ্ছা, in case of spherical mirror, the velocity of image, শর্টে বলে দিচ্ছি, is equal to minus of f by u minus f whole square velocity of object. Okay. আচ্ছা, now about refraction. I won't be dealing much with refraction. We all know Snell's law, which is, we can say that n1 sine theta 1 is equal to n2 sine theta 2. Okay. Now, there are a few things that I should mention, which I will take a few times. So, আমি একটা নতুন দিচ্ছি। আচ্ছা, till then, okay, before I start with this shorter revision of refraction, do one thing, do this particular sums that I'm giving you.
Okay.